Good morning everybody. Previously we learned about how to convert decimal to other number system, right? From decimal to binary, decimal to octal, decimal to hexadecimal number system. Today we will discuss about the conversion between other number system, conversion from other number systems to decimal number systems, right? Completely different scheme. We can use the following steps to convert the given number with base value b to its decimal equivalent, where base value b can be 2, 8 and 16 for binary, octal and hexadecimal number system respectively, right? Now step 1, write the position number for each alphanumeric symbol in the given number. Then get positional value for each symbol by raising its position number to the base value b symbol in the given number. And step 3, multiply each digit with the respective positional value to get a decimal value. Step 4, add all these decimal values to get the equivalent decimal number. Now binary number to decimal number. First we will convert this thing, a binary number to decimal number. Since binary number system has base 2, the positional values are computed in terms of powers of 2. Using the above mentioned steps, we can convert the binary number, the given binary number, to its equivalent decimal number. Now see, what is the procedure? A binary number to its equivalent decimal value as shown below. Convert 1101 to the base 2 into decimal number. Our given number is here 1101. This is a binary number. How can you understand that this is a binary number? Because here the base is given as 2. We write down the base here and this is the given number 1101, and we have to convert this number into decimal number. Now digit, you can make this chart. This is very easiest way to explain this thing. See, first of all, here is the digit. What is the digit given? 1101. Then position number. Position number means, what is the position of rightmost bit? 1. This is 0, then 1, then 2 and then 3. Now positional value will be 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. Now decimal number will be given like this: 1 into 2 to the power 3 plus 1 into this given number digit of the given number into its positional value, and then we have to sum up all those things and we get particularly 13. Here 1 into 2 to the power 3 means 8, 1 into 2 to the power 4 means 4, plus 0 into 2 to the power 1, 0 into 2 means 0, and 1 into 2 to the power 0. What is the value of 2 to the power 0? That is obviously 1, and 1 into 1 equals to 1. And after summing up all the values, we will get 13 to the base 10. Now this base value is important. When we are converting a number from some given number system to another number system, we have to just refer the base value here. For binary number system we use 2, for decimal number system we use 10, for octal 8 and for hexadecimal 16. Now we will convert octal number to decimal number. What is the procedure here? For binary number, what is the base value? 2. So when we calculate the positional value, we have to take the power of 2. Now for octal number system, we will take the base value 8 and positional value like this, power of 8s. Same procedure, but just the base value is changed here. In binary system, what was 2, that will be here. In octal number system, that will be 8 here. No other changes is done. Same procedure. The given octal number is 257 to the base 8. Now we have to convert it into its equivalent decimal number. What is the procedure? First write down the digits here, 2, 5 and 7, and the rightmost digit 7 is here. Position is 0, 1 and 2. Then positional value, how can we calculate this one? 8 to the power 0, 8 to the power 1, 8 to the power 2, and now multiplying the digit with its positional value and then summing up all those things. So 2 into 8 square plus 5 into 8 plus 7 into 8 to the power 0 equals to 128 plus 40 plus 7, and the resultant value will be 175 to the base 10. Okay, same procedure. This is octal number to decimal number, and now from hexadecimal number to its equivalent decimal number. Same procedure, just we change the base value here. Base value of hexadecimal number is 16. So the given number we have written here 3a and 5, their position numbers 0, 1 and 2, positional value 16 to the power 2, 16 to the power 1, 16 to the power 0, and then we have to multiply the digit with their respective positional value, and after that summing up all the values we get this number, that is 933 in the decimal format. And when we get the final value, we must mention the base value here. So this is the complete conversion. Conversion from what? Conversion from octal, binary to decimal number, octal to decimal number, and hexadecimal to decimal number. This is very important conversion. So we just completed all those things: conversion from binary to different number system, and from those different number system to binary system. The first part is already discussed in the previous video. You will just go through all those things. If there is any doubt, just comment me and ask me. I will definitely clear all those things. Okay, and then comes another thing, fractional part. Fractional part, conversion of a fractional part, it will be discussed in the next class. Okay, thank you. Please subscribe my channel for further notification and the entire discussion for the classes. I think it will be helpful for you. So please subscribe my channel, like and share. Thank you.